Hello. So, as I said, and you'll see in the first part of the video, I got all my bits, and it's so much fun. So it's now 8:41, and I've been messing around with all the bits, and now I have. I bought some custom crimp connectors because bullet connectors would have been easier, but they were expensive. But now I can make it work. So, took a little bit of time to find how to use the S because the controls were in Japanese or Chinese. I'm not quite sure what language specifically. One of those two. And I couldn't, for the life of me, understand it. So it took a little bit of finding out. And, yeah, works now though. So I don't want to power that up. Yeah. I always connect the red. That's irrelevant which one. Connect this one up. Then I can just play with this one because I don't actually have a switch yet. Forgot to buy a switch. How do you forget to buy a switch? Anyway, so as I said before, black is ground. This is an Omega 2560, which has some simple code on it, which I might diverge at some point. Divulge, spread. So ground to ground. Red pin is +5 volts from this big thing, so that powers the Arduino quite nicely. And then I have the servo control to pin 9 on the PWM. So, I'll show you in a minute. Then this I've labelled, and unfortunately this ESC doesn't actually doesn't have any colour differentiation, so I don't know which one goes where. But after a lot of testing around, I've got them marked, and as you can see, blue is just black. The red bit of tape's the red one, and the yellow one's the yellow one. So I marked them for easy remembering. I would plug them in all the way, but these crimps are so tight. So until I manage to loosen them off a little bit, that will do. And yeah, that is, if some will recognise, just a hard drive. I mean, not a hard drive, a slimline bay cover, which is just enough for me to grip it, cause it really goes. So now, you can see all my cables connected there. I've connected them all. If I just zoom out a bit, you can see the red, black, and white comes to there, and that connector there is left empty because it's the power one, and that's the black cable left free. I'll bring you back over here. And now, I really hope you can hear all the commands and settings it says, but I can put this down actually because this doesn't kick in straight away. I've got the code to give me a bit of time to react. There we go. We'll run it through its sequence once, then I'm going to unplug it. I'll just watch. So yeah. Oh, can't unplug it. Once it stops spinning I have 10 seconds, so that's just a basic sequence which I've got running only off the Arduino, no extra cables. And I'm hoping tomorrow to go past the hardware store to buy the bits to make the basic, a more sturdy mount, because currently a lot of the speed is lost in vibration. I mean, it vibrates. So yeah, I am really, look, just do it one more time because I'm really quite happy. So just in case anyone's wondered, all of these cables that come with it, except for those green ones, are silicon cables. So that's low speed. As you can see, it slowly speeds up and then goes full bore. And all my bits of paper go everywhere. So it's on a loop. It only does a startup sequence once, but it's got a 10-second break in between. There you go. Starts up again. Just gonna move my face out of the way because if it comes off it will hurt. Wow, it moves papers everywhere. Anyway, that's a very successful afternoon. So if everything goes to plan, I should be able to buy all the bits to make the body for how much did I quote it cost me? No, it cost about $40. No, it's a bit more than that actually. It'll be about $50 to build the full aluminium frame. But then I need to buy a hacksaw, so it's another 20, and some hacksaw blades because aluminium needs to be cut. But yeah, so far all these bits. Oh, I also got the. You can see my mess. Working on it. Oh, the other crimps, by the way. So these are 4.8mm standard. Oops. 4.8mm, just standard. They're the male connectors, they're female connectors. They're just standard crimp ones. Don't have an actual crimp tool, but that doesn't seem to be a problem. I managed to use normal pliers, as long as the normal pliers are actually big enough to reach it. But that's the charger, which so far I don't actually have a. Sorry, that's the end. So it's got the S2 and S3 connector. That's to connect to a 12-volt battery, which currently I've only got a small lead acid battery. I have yet to find an actual 12-volt 1 amp connector, but it works. The only question now is, can I actually run 3 of these 2 Niggy motors off this one battery? It's 50C, so I just grab my calculator and that's 50 times 3, it's 150 amps times 7 point, what voltage is this thing? 7.4 volts. Divided by 326. I can't run 3 of them at max draw. It'll be overdrawing the battery. But it shouldn't be going to max draw very well. I'll have to see how it works. All I need now is to get the 3 more motors, 3 more props, 3 more I'm not good at that word. Some cable, because I actually need to wire and all the extra cable. The Arduino will be very easy to run, and the frame and a gyro, and learn how to control it with the Arduino, and a height measurer, ultrasound, and all of those bits added together, if programmable, should actually give me a hovering drone. Though currently the code will be very raw. It's basically just going to say, if the height's above something, decelerate slowly. If the height's below something, accelerate not quite so slowly, because we don't have to go to boof into the ground, because I killed my calculator, because that'd be bad. But hopefully I better get it just to slowly increase itself up to a height, and then just hover like this. Hopefully the gyro's easy enough to program, because if it tilts this way, it needs to accelerate this one or decelerate this one, and if it goes this way, decelerate and accelerate, and it's going to have to handle height, and I'm potentially going to have a flying circular saw. Because by the way, this blade it looks a bit flimsy, but it isn't that flimsy. It's actually got quite a lot of waka in it, and it currently spins this way, which is actually the right way. How did I actually got it the right way around? Wait, that would be pushing air down. Yeah, that's right. Awesome. Cheers, guys. Bye.